Laboratory session 1, introduction. BDA 31003, final element method. Okay, you dah ada slide ni tak? Guys, do you have this slide?
Belum.
Belum doktor.
Okay, saya akan share dalam WhatsApp group kan nanti. Later. Okay, this is the link. You want to install the Lisa. Lisa is a user-friendly finite element method. Dia ada banyak jenis finite element method software for Windows with an integrated modeler, multi-threaded solver, and graphical post processor. Okay. Lisa can be found and downloaded from its website here. The latest one is 8.0. The pre-version has 1300 node limit. The license is perpetual and will never expire. This is open source software. Open source software. Okay, Lisa is 32-bit program that will also run on 64-bit Windows operating system. Itu introduction buat this one. So 32-bit program can access a maximum of 2 GB RAM. So Lisa is suitable only for small finite element model. Finite element mean kaedah finite element method kaedah unsur terhingga. Finite element. Okay, there are 4 requirements to install Lisa. Windows XP or later. Lagi baru lagi okey lah kan. Graphic card supporting shader model 1.1. Microsoft Net Framework version 2. Okay. In this case, you try je install. Kalau boleh, boleh lah. Kalau tak boleh, maksud dia your computer is not supported lah. Itu je. Support various analysis such as linear, static, dynamic response, model, vibration, steady and transient heat flow. So benda-benda yang you dah study before this like solid 2, solid 1, you can apply in this Lisa software in order to study the stress analysis, the linear, static, dynamic response, model vibration, steady and transient heat flow, steady fluid flow, CAD associate activity, and many more. These are the application of Lisa. Ini you buat simulation. Buat simulation then you apply some load. Sama macam you try macam solid 1, solid 2 lah especially. Okay, this is an introductory problem. Kalau you notice, this is a basic problem that you learn in solid 1 or solid 2. Solid 1 as well, we have this one. Or cantilever beam, you apply some load. This is the cross section of the beam, the length of the beam. Okay, the cantilever beam shown below is loaded by a single point load of magnitude 1000 Newton. Here, in the negative y direction, negative below, x positive, y positive. And then downward is negative, upward is positive, y. To the right is positive x, to the left is negative x. Okay, the beam is of length 10 meter with cross section of 4 by 4. Cross section 4 by 4. It is rigidly fixed at its lab. Fix it here. Okay, the material properties are, so should be there are modulus yang E 210 GPa 10 to the power 9 G giga. Poisson ratio, if you remember still, Poisson ratio is 0.3. This is unitless, no unit. And density rho is 7,800 kg per meter cube. the stress distribution is required to be determined. So determine the stress distribution on this beam. When you apply 1000 Newton load or 1 kilonewton load. So you can determine the stress distribution using LISA software. You need to draw this diagram first and then you define the geometry. Okay, later, okay. And then we will know what is the stress distribution. Boleh dengar saya semua
Boleh, Doktor.
Boleh,
cantik.
Boleh, Doktor.
Jadi saya tahu semua dah skor-skor ni, tak ada masalahnya. CGPA semua tinggi-tinggi kan. Tak apa, saya share action note ni nanti you all boleh review back. Ini senang je. Okay, these are the stages, the step in finite element method. So the pre-processing, you do the, you determine the material properties, geometrical model, the meshing and material assignment, constraint and load, and then you solve wing using the software, solve button on command. This is the in the software, and then you do analysis. Post. Pre, solve and post. Result, what is the, you will get the result, what is the deformation, and then the animation, the data, the image. Pre-post. Okay, pre-post type of analysis, defining material properties. Okay, in this case, okay, this is the material properties. What is the Young modulus? What is the Poisson ratio? What is the density? This one is under pre-post. Creating geometrical model. Okay, you draw the shape. In this case, let's say in this case is the beam. Element meshing and material assignment. Apply constraint and apply load at any. In this case, there is a load 1 kilonewton. Okay, from the main screen, double click. Okay, this is the type of analysis selection. From the main screen, double click analysis. You can see this once you have installed the software. You can try this. LISA 8.0. It is under static 3D because the diagram is 3D, not 2D. This is a 3D. See, this is a 3D. If there is 2D, only the page, the front view or the side view. Now you get all the, it is under 3D default static. This is under 3D view. Okay, a global properties dialog appears. Okay, this dialog will appear. Then under general tab, select 2D, static 2D. The reason to select 2D dimension is the beam will be seen from planar view as a plate, and the cross section of the beam is the same as the thickness of the plate. Okay, this is how you analyze. A global properties dialog appears. Then under general tab, select 2D. Then static 2D. The reason to select 2D or 2D is the beam will be seen. This is how you analyze. The beam will be seen from planar, mean from the top. And the cross section of the beam is dim as the cross section, dim as the thickness of the plate. Okay. This is the cross section. It is better to solve under 2D. From the main screen, double click analysis default. The default is static 3D. Okay. Saya pun belum install lagi ni. Belum try lagi. Nanti kita try lah next week. Next week kita try. Example one. Very many example. Jangan takut. Global, okay, settle. Okay, this slide settle. Material properties defined in this step will later be assigned to the element that are going to be created. Select material menu from the model menu. Default 0 element. Assign new material. A blank material dialog appear. Click add. Then in geometric tab, select plate, shell, membrane and enter a corresponding thickness. In this case, the thickness for the plate is 4. This 4 by 4. So you can just need to enter 4. Switch to mechanical tab. Select isotropic option. Enter the Young modulus. Okay, isotropic. You should know also what is isotropic. What is isotropic? Means enter Young modulus 210. Okay, 210 and Poisson ratio 0.3 value. Then close to exit the dialog. Okay, after you have installed this one, the list software, I ask you to try this example. Otherwise, later on, if you don't understand this example, saya takut you tak dapat buat yang later yang example yang lain nanti. Saya rasa Dr. Hafiz dah ceritakan pasal test 1, test 2. That one is under kuliah, not under lab. Lab, we just do the experiment. We just do the exercise. Okay, boleh sentuh tak? Berapa markah untuk lab? What is the ratio? What is the portion? Untuk you punya final exam nanti. Ada orang tak? Saya seorang je sekarang ni.
Lab test 3 kan doktor?
Saya tak nak saya cakap seorang-seorang je. Berapa persen daripada lab dan berapa persen daripada kuliah? Saya tak ada RPP tu. Saya tak ada lesson plan tu. Pasal itu ada pensyarah tu, Dr. Hafiz. Tak dengar dekat outer dah ada semua slide. Ini Mr. Ng Ziyong dah bagi tahu You can download daripada sana. Saya tak payah share. Dekat outer dah ada semua slide. Pasal saya cuma jaga, you kena tahu, you must understand there ada dua bahagian sini. Satu ialah kuliah, satu ialah lab. Saya cuma jaga lab. So kuliah is under Dr. Hafiz. So the under outer tu, the outer is controlled by him, not me. I only give mark for your exercise in this lab session. This lab session, I will give mark for this lab session only. Not for the kuliah. Ni kat sini je. Mr. Ng Ziyong. Dekat outer dah ada semua slide. Dia rajin-rajin lah buka outer. Okay, ni tadi dengan keluar window lain. This is another window. Again, we choose plate or shell membrane. Not C section, bukan T section, bukan L, bukan I. Kenapa bukan rectangular bar? Okay. Okay, thickness for, this is the thickness. Geometry, mechanical, isotropic. And then this is the modulus yang 210 gigapascal, 210 exponent 9, 210 10 to the power 9, 210 giga. Poison ratio 0.3, density 7800. And then renaming the material, select. Yeah. Telefon dah, okay. Select rename type steel, okay. Tak ada masalah, it's just untuk you familiarize with the software only. This example is for you to familiarize with the software. Mana satu nak rename, mana satu nak choose the type of material. Okay, on the main screen, select new node tab, then enter the coordinate of the four corners of the beam as seen on XY plane. Click new node. Okay, this is to do the meshing. Enter 00. Click add. And then 10, 0. Okay, this is the length just now, 10. Click add. Okay, 10. Cartesian coordinate, okay. And then 10, 4. This is the thickness tadi. 4 by 4. Click add and then 0, 4. And then this you determine the geometry of the beam. Yeah, tadi beam tadi. Okay, 10. And then 4, 4. Senang cerita, you gonna try. Kalau you tengok slide je, you takkan faham. You install, later on you try. Ambil masa yang sambil baring-baring borak-borak tu, boleh try. You kena pakai komputer lah, tak tahu dekat handphone. Boleh ke dekat handphone? Saya tak boleh. Click add. Hit close button when you have enter all the coordinate to exit the dialog. Okay. To view in XY plane, to resize the model, to fit the screen and to show the node numbers, click all the following tab. XY view, fit to screen, show node and element number. All 4 nodes with number in XY plane, 1, 2, 3, 4. Okay. To create the 8 node element, we could create more nodes in between the 4 existing nodes and then join them up to form 8 node element, or we could create 4 nodes quadrilateral element and use a feature in Lisa preprocessor to automatically convert the 4 node element into 4 node element. Macam lah. We shall choose the latter alternative. Okay, we choose 8 to create the 8 node element. Use the add signal menu from the element. Kenapa? 1 into 8 node. Macam mana? On the display dialog, select the. Saya rasa ini kena try lah. Saya nak explain tu pun tak boleh nak imagine kan. You all tak boleh nak imagine lagi. Okay, this is for creating element. Settle to the element and then assigning material properties to element. On the display menu, select default one element and verify that the element properties component being created is assigned to the default material, which is steel. Geometry analysis. This is the second stage actually. Oh, first stage, pre-processing. Pre-processing yang ni tadi. Masih lagi pre-processing. Masih kat sini. Material property cuma model, element matching and material assignment. Element matching and material assignment. And then lastly constraint, baru selesaikan problem tu. Changing element shape. To change the mesh to 8 node element, you can either click the icon on the main menu or select change element shape from the mesh tool menu. You boleh guna button ni atau guna daripada mesh tool menu. Macam the, you can either click the icon on the icon or the mesh tool menu or the menu. Changing element shape. Select the radio button to change from quad 4 to quad 8. Quad 8. 2 kali quad 8 change from quad 4, change to yang tadi ni dekat. Ni tadi dekat mana? Saya tak boleh nak explain everything. At least you kena install the software and try this example. And then applying constraint. And then apply load. A vertical load of 1000 Newton acts in the negative Y downward and has to be applied to the right tip of the beam. Select the node at the top right corner. Okay, this is the load. To rename the load, go to the name selection. Okay, this is the. Okay, to rename the load. Bring the cursor on the unnamed one node, right click, then select rename. Okay, rename. Tak ada apa lah. First class maybe you takkan faham lagi. No problem lah. Second class, second lab. You ada 14 weeks, don't worry. Click OK to exit the parent dialog. The model display will update to show the apply load. So this is the XY direction. This is the X positive, Y positive. Okay, the apply load is here. Downward, negative. Satu, dua, tiga, empat. This is all automatic lah. You tak payah nak fikir apa. Semua in the software. To solve the model, go to file menu. Then okay, this is the second stage 3. Pre-post, solving, and then post. Okay, this is the second stage. To solve solving stage. Yeah, remember. To solve the model, go to file menu, then select solve. Don't forget to save your work. File, save or file. Save as if you want to save as different name. Okay, this is solve. Mana ni? Okay. Tools. Solve. After the solver has finished, click the post processor button to see the result to animation and other viewing result. Okay, you can. This is the post solving. Various viewing feature. To reorient the view of the parallel to the monitor, use the following menu or tool button. Okay, one miss the stress. If you remember, this is you learn this about this one. The stress in your solid 2. Ingat lagi tak? Solid 1 tak ada ni. One measures lagi satu apa? Dia ada lagi. One measures stress. Baru dah lupa. Solid 2. Okay, this is the view, the result in term of displacement. In this one is in term of one measure stress. What is one measure stress for? So you kena buka balik lah. Kalau you tak ada lupa dah solid 2, kena buka balik lah. Then from that you can do analysis. Ada yang masuk, bawa masuk. Then double click table under solution menu list. Okay, you can get all the data. Yeah. Animation and graphical option. Okay, finish. Thank you. Itu ya. So what I want you all do is install the software first and then try this at home. This example 1, this introductory example, this introductory problem, because we have many other problem to solve later on. Macam mana lagi ni? Sini. This one is axial load. Axial element. And then we have truss. Truss in 2D, truss in 3D, and then beam, and then frame, fluid flow, heat fin, heat wall, 2D heat plate, shell, solid. 13. Ada total 13 experiment. Kita buka tak? Okay. So actually everything is, all this experiment, all this example, everything is in, semua dah di step by step, all are explain step by step. You are asked to do the example and then we will give you an problem, give you a problem, and then you have to solve the problem and then submit within 2 days. Submit to author. And then I will do the marking.